Welcome to Astronomy Daily, the podcast that brings you the latest happenings from across the cosmos. I'm your host, Anna.
And I'm Avery. It's great to be with you. We have a packed show today, covering everything from newborn planets and rogue worlds to a major upgrade for one of Earth's most powerful telescopes.
That's right, Avery. We'll also be looking at what makes an interstellar visitor so familiar and peering into the very exciting future of spaceflight. So let's get started.
First up, an update from low Earth orbit. Starlink has announced plans to adjust its satellite constellation in 2026, primarily for space safety reasons.
Right. This is a significant move. They're planning to lower the entire constellation from its current altitude of about 550 kilometers down to 480 kilometers.
And this isn't just a random adjustment. It follows a recent incident where a Starlink satellite broke up, creating a small but notable amount of space debris. This move is a direct response to mitigate future risks.
Exactly. A lower orbit has a key advantage. Atmospheric drag is stronger, so if a satellite fails, it will deorbit and burn up in the atmosphere much faster, in a few years instead of decades. This drastically reduces the long-term risk of collisions.
It's a proactive step towards managing the increasingly crowded environments in low Earth orbit, a responsible move for a company with such a massive presence up there.
From our crowded orbital backyard to the nurseries of distant stars, Gaia Space Telescope has given us an unprecedented look at planets in the process of being born.
This is incredible news. Gaia has found compelling evidence of planet formation in 31 different young stellar systems. We're talking about seeing the very first stages of planetary life.
It really is, and the method is just as brilliant as the discovery itself. Gaia isn't seeing the planets directly. Instead, it's detecting the tiny gravitational wobble that these forming planets exert on their host stars.
That gravitational wobble, it's the same principle behind many exoplanet discoveries, but applying it to these incredibly young, chaotic systems is a huge breakthrough.
It allows astronomers to study these systems in their infancy on a large scale for the first time. We're moving from theoretical models to direct observation of how solar systems like our own might have formed. It's a whole new window into planetary science.
Speaking of new windows, how about this? Astronomers have successfully weighed a rogue planet for the first time.
And for our listeners, a rogue planet is one that drifts through space, untethered to any star. They're incredibly difficult to find, let alone study.
Exactly. This one is about the size of Saturn, and it was likely ejected from its home solar system billions of years ago. Using a technique called microlensing, scientists were able to measure not just its mass, but its distance from us as well.
And the secret ingredient here was parallax. They observed the microlensing event, where the rogue planet's gravity bends the light of a background star from two places at once, Earth and the Gaia Space Telescope, which is about 1 million miles away.
That different perspective gave them the data they needed to calculate the planet's properties. It's a fantastic proof of concept for a new way to study these isolated wandering worlds. It makes you wonder how many are out there.
From wandering worlds to interstellar visitors, our third confirmed guest from another star system, Comet 3I/ATLS, has been revealing some more fascinating secrets.
It certainly has. As the comet was moving away from the sun, the SOHO spacecraft observed it producing an absolutely massive amount of water.
Right. The solar wind was breaking down that water vapor into hydrogen and oxygen. SOHO's SWAN instrument, which is designed to look for hydrogen, detected this huge hydrogen glow surrounding the comet.
And what's so significant about that?
Well, it means this interstellar comet is behaving in a way that's very similar to comets from our own solar system. They also release large amounts of water as they are heated by the sun.
So it's a piece of another solar system, but it's made of the same stuff as ours. That's a profoundly important clue about the composition of planetary systems beyond our own. It suggests the building blocks for worlds like Earth could be quite common across the galaxy.
That it does, and it shows the Three-Eye Atlas has untold stories to tell us as it heads on out of our solar system.
Let's shift our gaze from the distant past to the very near future. 2026 is shaping up to be an absolutely massive year for space exploration.
Oh, I am so excited for this. The headline mission, of course, is NASA's Artemis 2. We're finally sending astronauts back to the moon, or at least on a trip around it. It will be the first time humans have been in deep space since the Apollo program.
A huge milestone, but it's not just NASA. The commercial sector is also making big moves. We're expecting the debut of new commercial space stations and the next generation of private lunar landers.
And we'll be getting new eyes on the universe, too. The Nancy Grace Roman Space Telescope is scheduled to launch. Its wide field view will be revolutionary for studying dark energy and finding exoplanets.
That's right, and not to be outdone, China's launching its own powerful space telescope, Suntian, which will have a field of view 300 times larger than Hubble's. It's going to be a year of incredible advancements across the board.
Finally, let's come back down to Earth for our last story. The Atacama Large Millimeter/Submillimeter Array in Chile, better known as ALMA, has just completed a major upgrade.
ALMA is already one of the most powerful radial telescopes on the planet. What did this upgrade involve?
Engineers installed 145 brand new low-noise amplifiers across the array of antennas. In simple terms, this will massively increase the telescope's sensitivity. It's like giving a giant ear a state-of-the-art hearing aid.
Wow, so it will be able to pick up even fainter signals from space. What kind of science will that enable?
It's going to give us a much clearer view of the cold universe. ALMA excels at observing things like the dusty disks where planets are forming, the cold gas of the interstellar medium, and even complex organic molecules in distant galaxies. With this upgrade, those views will be sharper and deeper than ever before.
I love all this new science we have to look forward to.
It's a powerful testament to how this new telescope is not just confirming old theories, but actively rewriting the first chapters of cosmic history right before our eyes. It's a true revolution in our understanding of the early universe.
And that's a wrap for our news today. From managing our orbital highways to discovering newborn planets and gearing up for humanity's return to deep space, it's been an incredible tour of the cosmos.
It certainly has. Thanks so much for tuning in to Astronomy Daily. We hope you'll join us next time for another look at the universe around us.
For more space and astronomy news, follow us on social media. Just search for Astro Daily Pod on all the major platforms. And if you visit our YouTube channel, please give us a thumbs up and a follow. It really helps with the algorithm recommending us to other space enthusiasts.
Until tomorrow, keep looking up.